Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is word pattern. So let's go to LeetCode, give this problem a read. Okay, so given a pattern and a string s, find if s follows the same pattern. Quite simple, right? Here follow means a full match such that there is a bijection between a letter in pattern and a non-empty word in S. Specifically, each letter in pattern maps to exactly one unique word in S, and each unique word in S maps to exactly one letter in pattern. No two letters map to the same word, and no two word map to the same letter. So we have done a similar problem, which is right here, which should be right here, isomorphic strings. So isomorphic string is a pattern matching between two strings, but here they have just, instead of, so s they have given as like a list of or like a string of words, and word need to match basically these strings in the pattern this time. So it's just like a little bit of difference, but we know how to solve it. We have already solved the previous problem, but if you haven't, we will discuss it again. So what they're asking us, I've taken the first example here. So we are given pattern, and then we are given this string which contains some words. So what they're asking us is find out if basically these two, the pattern and the string, they basically follow the same pattern. That's what we are checking. How do we check that? Well, they have strictly defined that like each word has to be mapped to just one letter from the pattern, and one letter from the pattern has to be mapped exactly to just one word. So what they're saying is, let's say this A is mapped to dog, and this B is mapped to cat. Then this B, because now I am at 0, 1, 2, and 3, I'm at second index, then right over here, this needs to match to basically what I have seen before for B. So B, I mapped B to cat, and now it has to map, basically, B has to match the cat. Now next is A. I have already done the mapping here, so A need to be mapped to dog. So here you can see there's these two follow the same pattern, same pattern, and if they follow same pattern, then we need to return true, otherwise we return false. So how do we actually do that? Well, one way would be, how about I just do a two-way mapping between pattern and the word inside my string. So I'll create a map, I'll call it PS map. This is like pattern to string mapping, and then I will have string to pattern map. And the reason I have these two maps is so that I can check basically two-way mapping. So let's say I'm going, basically, first of all, these two to be able to follow the same pattern, their length have to be equal, right? The length have to be equal. So first we'll check that is an edge case. If they don't have the same length, that means they can't be following the same pattern, right? So that will be the first check. Then once you see come over, let's say I'm at A right now, so I will be traversing over the pattern. So I come across A. Is A in my PS map? Well, it is not. So what I'll do is I will put A, and then I will map it to dog, because this is the first time I'm seeing these two, this key, basically, I would say. If I'm considering all this string in my pattern as keys, so this is the first time I'm seeing A. All right. So then also I will do the opposite way mapping as well. So I will map dog to A, right? So this is the way I will do the mapping. Then I will come to B. In the B, I will map B to cat, and here I will map cat to B. Then next I will come across, so these two are done. These are two different keys that I saw in my pattern, and then I've done the mapping. But then I will see B. Does B exist in my PS map? Yes, it does. It's right here. Then because it already exists, and I was only I was only allowed to map it to just one word. Now at index 2, I'm seeing this B, and then I'm seeing cat. Let me check in my map if the cat is mapped to B and B is mapped to cat. So I will check two-way mapping. So what I'll do is I will go and check if B has cat as its mapping, which it does, so this maps. And then also if cat is mapped to B, which is it does, so yes, this follows the pattern that was basically asked in the problem. So this B is already mapped to cat, and cat inside my SP map is also mapped to B. Then I will go next, I have to do the complete pattern mapping. Then I come across A, and then I'll basically check if A is in my PS map. Yes, it is. That means the mapping has already been done. So that is why now at third index I am seeing A and dog. I will go check in my map if A is mapped to dog now, because now I see this dog. If it was mapped to some other word like a crow or lion or tiger or something, then it wouldn't be a perfect mapping, or they won't follow the same pattern, you can say. Then here see, yes, A is mapped to dog and dog is mapped to A, so that means these basically follow the perfect mapping. Both of these, the pattern and S, they follow the perfect mapping. Well, in case you came across some difference right here, then in that case you will return false. Otherwise in this case you will return true. So let's discuss the time and space complexity of this solution. Time is big of n, because if n is the length of pattern or string, and space complexity is also big of n, because I'm using a map to store basically each string. Let's say if there are n distinct string, right? So that is why. If our pattern only contains like 26 letters of but actually we will have to get through the entire n length. But distinct, they could be 26 letters if they're only talking about like just lowercase English letters. But anyway, so this will be the entire solution. We've gone through the time and space complexity. Let's write its code, which is going to be really simple because we have done the similar problem earlier. Isomorphic string, that is the problem I'm referring to, and you can go check it out. Let me move my iPad. Okay, so as I said, so pattern to string map. Pattern to string map. So it's better to have just PS map, and initially it's a default dict, right? Default dict, and then I will have SP map, and I don't even have to like have it as default dict. I can just simply declare these as PS map, pattern to string map, S to map, string to pattern map. Now if, let's check it, if length of pattern, and I really want to actually get all the words of this S to, I will split it, S dot split, and we are splitting it by space so that I have all the words. Okay. Now if the length of the pattern is not equals to length of words, then I would actually return false, because they're not even same length. So how would they follow the same pattern? So I will return false. Otherwise these two maps right here, and then we can for, let's say, P in pattern, so I'm gonna assign these. So in pattern PS, so this P is mapped to P is mapped to, or I would actually do I and enumerate so that I can also access this corresponding word in the words as well. So I'll say enumerate this. So now I will call it word, and let's get it from the words at the ith index. Let's append this. So this will be storing the word for P, and SP will be storing the pattern for the word, right? So for word, it will store the pattern, so which is P. Now tell me, let's say this is the scenario when you didn't come across basically that word, right? You didn't come across that word. But if you came across that word, then you would want to check it. So if this P already exists as a key in your PS map, and inside this map, this P does not match the word, that current word that I'm seeing, corresponding to the current ith index. So if that is the case, then I will return false, or I will also check that same thing inside my SP map, but not for the P, for the word. Okay, so if this word already exists the other way inside my SP map, then in my SP map this word has to be equal to P. If it is not equals to P, then I will return false. Okay, I will return false. Otherwise these two should execute. They don't have to execute if this else case, if they already are present. We can also put else here, but this should run fine, because it could assume that we are overriding those values, but like it wouldn't change, because if they were different, then we are returning false anyway, so it shouldn't change anything. Then if you have been through the entire string, just like we went through in the first example, that we just went through, then we can just return simply true. All right, so this will be the entire code. It's really simple. Let me zoom out and test it on our example cases. Awesome, so let's submit. Great, so we already talked about the time complexity is going to be big of n. N is the length of words or pattern. For space complexity, it will be big of 2n, because we are using these two maps, or hash maps, or dictionaries, whatsoever. So big of n or 2n, whatsoever. Then let's go back to AlgoYogi, mark this problem solved. Where is it? Right here. And then, all right, so see you guys later in the next problem. Until then, bye-bye.